Well, good morning everybody, and welcome to another edition of CGS Live VFX Special. I'm going to keep on the same project that I was working on last week, which was the Spaceship Rising, because there's still quite a bit to do on that. So yeah, without further ado, let's just dive straight in. And this is what I ended up writing to disk after the last stream. So I thought it's a good point to start, just have a look at it and talk about, the things that are kind of, need to be fixed, things that are working, things that aren't working. So yeah, hello to everyone that's joining me so far. I hope you're having a good weekend or had a good weekend. And I've resisted the temptation to work on this during the week, so I just left it so we can start exactly where we left off, and just go from there. All right, so I mean the things that are sort of a little bit weird. Hey Audrey, how's it going? How's your weekend? The things that are a little bit weird for me are the jumpy pops. They're not too bad, but they're a little bit too chaotic, I think. So calming some of that stuff down. And also with the streams, the pop streams that I did, they're very linear. So it's cool that they're very kind of perfect lines. That's what we were sort of going for, but I'd like to try and make them feel a little bit more organic and a little bit more watery. So, that's something that should be pretty easy to break up, hopefully, with a little bit of noise, a little bit of variation. I think the two elements together work pretty well. We could potentially have less of these pop streams as well. But it's also worth kind of rendering those pop streams just to see what they look like, because when you render it, they're going to be pretty thin, pretty small. They're not going to stand out as much as they do here, so it may be less of an issue. Now with the flip sim, I like what's going on when it pours off the ship, but I'm not loving this kind of feeling because it's just sort of pouring out over the surface of the ground plane that we have in there. It's not really, looking like it's part of the ocean surface at the moment. Yeah, my weekend was pretty good, thanks. What did I do? I've got a house inspection coming up, so I was tidying and mowing the lawn. Not very exciting. It's very cold here at the moment too, so it wasn't great fun being outside all day. But that's okay. I didn't turn my computer on once, which was great. So yeah, I'd like to improve this, and I might look at that first, and then have a look at the pop streams, and then we can keep looking, and we'll look at some rendering hopefully today as well, just to have a bit of a start at seeing what our thing looked like, and maybe starting to treat some of this stuff with materials, and just see how it's all kind of working. Alright, so I like this pattern that I'm getting on the top there. I think that's looking really cool. I think maybe this probably needs to be a slightly higher resolution, possibly. Don't know. We'll see. So the water, let's take a look at the flip simulation. Oh, before I jump into that, I created this. This is the only thing that I did do, just so I could visualize it better. When it comes out of pops, it just looks like this, and it's okay, but I really like this way that flip creates the visualizer from dark blue to white. So I wanted to replicate that. And just to quickly show you how I did that, I just take the velocity that's present on the particles in a VOP, I run it through a length, which calculates the magnitude of the vector. So V is a combination of direction that the particle is traveling, but also the magnitude of the speed that it's traveling in that direction. So to separate just the magnitude, the speed, you do a length, and that will calculate how fast it's traveling, not the direction itself. You can see it's a float that it outputs. Then I run that through a fit, because the speed might be greater than 1, and I can adjust that. You can see as I run that through, that as I increase that source max, I get that gradient changing. So I think I had it at 2. And then I run that through the color ramp, and that color you can see is just blue to white with a different color in the middle. If you do just straight blue to white, it sort of doesn't quite look as good. So put that one in there. Oops, I guess I can just undo. There we go. So I did the same thing on this side too, just to get my flip visualization back. Otherwise, it just becomes a little hard to kind of see everything. It's just all white. But with the speed visualization on, it's easier to see, you know, where are the fast parts and where are the slow parts, and it looks a bit more three-dimensional as well. So I find that handy. Now, we're going to look at flip. So let's go back to the first frame, have a look at our .NET. I think I might have taken the resolution down slightly for the cache, I can't remember, 0.05. Now we have our ship as the collision geo, and we've got our ground plane. But that I need to replace with my water surface. So here's my water surface. I was looking at this in the flipbook as well, and the speed of the waves looks a little bit crazy. I mean, it's quite low resolution, so maybe it's fine, but it looks a little bit kind of jittery. So I'm going to just go back to my water surface here, and let's just have a look at that. So turn on real time. It does look a little bit crazy, but let's just create a different grid here, and I'll just go 800 by 800. Lots of detail now. Let's just do a little flipbook of this. So I don't want to stamp over this flipbook, so I'm going to choose Start New Sequence, and then hit Start. And now it's writing out a separate sequence. My colors are all messed up, but I'll fix that in a second. Actually, I can fix it now, maybe. Okay. Oh, yeah, it doesn't let me do it while it's playing. Okay, at least I can see it. So yeah, it's a little bit kind of turbulent, crazy, a bit flickery. Especially for the scale that this is, you know, you would imagine it'd be quite a bit slower. Alright, so let's go to our ocean spectrum, and we're going to take, what are we going to do? Let's take the chop down. It's a little bit choppy. Doesn't really seem to be changing much. Take the speed down, amplitude, take all that stuff down. It's probably better. It's starting to look a little bit, whoa, don't change that. It's starting to look a little bit larger scale now as well, which is good. I'll play with this a little bit as well. We've got time scale as well. I guess we could just drop that, and that will overall make it feel a bit slower. Let's try that. Let's hit escape on that. No, it's still a bit. I mean, it's better, but it's still a little bit too crazy. Let's see, ocean spectrum. I guess, yeah, we could just keep dropping the timescale down, but I kind of think that you know, I want to. I mean, that would be interesting, but is it the chop? Maybe amplitude. Let's take that down. Reference wind. What happens if we crank that up? Let's take this down. 0.5. So you can speed both effects, you know, amplitude as well as the kind of speed of this stuff. This is not, you know, it's not something that I do all the time, so it's a little bit of trial and error to figure out what the kind of setting is that I want. Let's have a look at that. Everyone's very quiet today. Who else have we got? Yeah. Don't be shy. Alright, let's have a look at that. It's a little better. I mean, maybe the my kind of grid size as well is, you know, a little bit too small. So I could, let's try setting that 50. See what that gives me. Many things in life are trial and error for me, Audrey. Just, yeah, I mean, it's a good way to be. Just try. At least you're trying. Well, yeah, I guess, you know, it's good when people talk because it means I don't feel so alone. Hey, Alan, no, comments are more than welcome. It's not, you know, this stream and all the CGS streams are, you know, free for the public. It's not just meant to be specifically for CG Spectrum. Sometimes I talk about, you know, things that are specifically for CG Spectrum students, but no, please, you know, anyone who's watching it, this is not just for CG Spectrum students. So I want you guys to comment if you feel you want to, or ask questions. I mean, I'm not loving this, but it is better, so I might go with that for now. Let me switch back to my other grid here, and I'm going to. And thanks for joining me, Alan. So I'm going to come back here, and let's go. What are we going to do? We're going to take this here, and we're going to poly extrude. Actually, not poly extrude. I'll do an extrude volume. Oops. There it is. Extrude volume. That just extrudes it straight down, like that, to create a volume. That will then allow me to do a VDB from polygons. Oops. Like that. Let's take that down. And then I'll create a null for that one there, as well as there. And this one can be called out, water geo. And this one can be called out, water VDB. And then I'm also going to do a trail up here. Calculate velocity, just, don't know, can't remember if we do. No, we don't have velocity on there. So I'll trail that to compute velocity. I'm also going to put a facet down to compute normals, so pre-compute to get point normals. And it's really important to have those things on for collisions. So normals are just kind of pretty much pointing straight up. But the velocity, if we label this marker correctly, we can see it's a velocity marker set to vector. And you can see that I've got some changing velocities on here. And that will be imparted onto the flip when I simulate with it. So it's definitely good to have it on there. Otherwise you get kind of not a great collision. So always put facet and a trail. Even if the thing is not moving, it's good to have a velocity that's 0, rather than not have one. Okay, so we'll duplicate this static object, replace that. You can on the ground plane, and I might try this and see, but actually, no. I think it's just based on, I think it just takes transform. It doesn't actually do the mesh itself, although I just remembered there is a terrain object. So we could try that as well. Let's do the static object first, see how slow it is. So we'll do out water geo. Hey, there we go. And we'll do out water VDB here. And you can see that the ship is through the geo at the moment, which is okay, because it should only start emitting once it's above. And let's just see how long this takes. Play. It's a pretty slow simulation at 0.05, so I'm gonna take that down to 0.1. Hopefully it'll be a bit faster. You can see down here, it keeps flashing up high-res VDB collision read back. So tells me that this high-res VDB collision which is reading off my D drive, which is not solid state, is a kind of slow point. Well, let's have a look at these file sizes. So it's 5.25 gig of collision, 22 meg per frame roughly. I'm gonna just move this from here. Is my stream Spaceship Rising Geo. Here's my high-res VDB collision. I'm just going to copy that, and I'm going to find somewhere here. Let's just call this one Spaceship Rising. And let me just also double check that I have space. I've just barely got space on here. I'm going to paste it onto my solid state drive and see if I can read it from there and whether it will, you know, be better from there. So I'm going to change this to my E drive. Let's see, Spaceship's Rising, Iris VDB. I'm going to grab it from there. Still copying by the looks of it. But this now scrubs pretty well. Solid state drives definitely have an impact on simulation time. You know, that read. You can see it's now not flashing that up. It's now flashing something different, which is talking about the collision mask that it's building. So the collision is still the slow part here, but now that read is not the slowest part. So that's interesting. I mean, I've definitely noticed that, you know, since having a solid state drive, that it definitely improves simulation time, and I notice it when I don't use it. So if you've got cached sources and cached VDBs, you know, for collisions, then it may kind of make sense to try and run them on a solid state drive if you have that option. Let's have a look. This is a pretty big simulation by the looks of it. I mean, look how few or how small a cache bar we're getting here. We only have this so far. So our collision probably is taking up a lot of our cache memory, perhaps. Let's turn on our collision guide and see. Well, it's adaptive, so it is only in that kind of area. Let's take our particle separation down a little bit more. The other thing you can do to, you know, to test, I mean, it's obvious to me that it's probably these things, but the other thing you could do to test is this. Turn them off and see how quickly or slowly it works. And you can see, obviously, it is the collisions that are doing that. Let's leave the ship off for now, and we'll just run with the water. You can see the water isn't actually too bad. So the ship is the thing that's really heavy. Maybe I did it too high res, or, I mean, it's good to have it because we really need that detail, but it's obviously a bit of a sticking point. One thing I could try is downsampling the VDB as well. It's just to help speed things up. I mean, you do want it to be high resolution. You can see now we're getting more out of our cache bar as well, so that ship geometry, that ship volume is really taking up a lot of precious cache memory. Alright, so we've got some collisions happening, that's good. It's good to see. And this, let me just check, this should be dynamic, but yep, so this is deforming, that's good. We want it to deform because this is ocean, so there we go. And we'll let it keep going. What we should see is that it's, you know, doesn't just sort of spread out like it was. It will probably still spread out, but because there's little undulations in the surface, it should sort of break up a little bit more than just be this big sort of very smooth thing. If we go back to our flipbook and choose sequence list, go back to our original sequence. Whoa, look at that. Turn this back to LUT. Why are you doing this? I installed like the ACES workflow, and I kind of regret doing it because it has made everything more complicated with color spaces. Even though, oh, there we go, turn it off. Even though, you know, it is purported to make things look better, I find when I'm working at home, it's kind of less important for me to do that. Because I can grade stuff in Nuke anyway. I don't know, it sort of doesn't make sense to me. It makes sense in a studio where you're sharing stuff, but me working alone, it just makes things more difficult, I find. But, you know, I may get used to it. So yeah, I want to break up this kind of really smooth, just round shapes that I'm getting. So let's have a look at that. You can see, you know, what's happening. I'm getting this sort of... I mean, I don't have the ship in there, so it's going to be different. But you can see an undulation on the surface. You can see it wobbling and wriggling about with the ocean. So it's taken on that sort of ocean motion. And that should really help. That should really help it sort of, you know, look like it's a part of the ocean effect. So that's cool. I think that's good. You know, we can kind of let that keep going. What I might do, let's turn the ship back on. So I might try this with my ship because it is really slow. Here we've got VDBs from polygons at 0.025, but we are only simulating, well, at 0.2 at the moment. Let me copy this parameter here. And I'm going to, after my high-res VDB collision, I'm going to do this. I'm going to do a VDB resample. And this will allow me to use voxel size. There we go. So you can see voxel size of 1 has made it really, really small. Let's do a voxel size of paste relative reference. Now it's taking the voxel size from, and so the VDB resample is a little bit slow, but now it's taking the voxel size directly from the flip sim, so it will match. So that's kind of interesting. So we take that down to 0.1, the one outside becomes 0.1. Maybe it's just going to slow everything down again, I don't know, but it might not be a bad idea just to keep everything at the same particle separation. I don't know, it's a little bit slow. Let's try turning it off and see how it goes. Reset. It's kind of the same. Hey Hardik, how's it going? Hope you had a good weekend. I haven't had a chance to reply to your email yet, sorry. I haven't been on my computer this weekend that much. But I will get back to you. So yeah, I think this is going okay. I'm gonna write this to disk in the background, hopefully. Although I've been having a lot of trouble trying to write things to disk in the background. Flip simulation version 1. Let's do version 2. Hope we don't run out of cache. Need another hard drive. Yeah, I'm going to do save to disk in background. It's going to ask me to save, so I'll save, and then hit save to disk. And it looks like it's working, which is good. And there's our render running in the background. Now I can close Houdini and that will keep running, which is great. Couldn't shut down my computer, of course, but I can close this, I can open a new file. This has now spawned a separate instance of Houdini. You can see that here, HPatch. So that's what's running. You can see that's taking all the CPU and memory, although not as much as here. But that now, I could close this instance of Houdini, and that would keep running. So that's really useful. But now it also allows me to keep working, and I can just check that that is running. There we go, so we've got that much so far. Great. Let's have a look at our pop streams while that is writing to disk. Hopefully we'll be able to do two things at once and my computer won't die. So we've got this for our pop streamers. You know, they're simulating static, which is really good, makes it very efficient. Then we're post-transforming with the same animation that we have on the ship. Then we have our point vop, just giving a bit of color. So yeah, I think these would be better if they sort of, Where's our ship? Ship's gone from wherever it was. I guess did I unplug it or something? Maybe I did. There we go. Oops, not that one. That one there. There we go. Alright, so here's our ship. And I think these ones are just a little bit too straight. Just a little bit too linear. Hey Peter, how's it going? Thanks for joining me. So I want to try and break those up. So let's start looking at that. Got our pop net. Let's hit play. Nice and fast. Compared to flip, it's a dream. So we've got this very linear line here. So I'm going to just try, under attributes, add a little bit of inherited velocity. I think I tried to do this last week as well, but I'll persist with it. And you can see already that breaks up that line, but it's a little bit much. And maybe I don't want to do it right at the start. So maybe I want it to sort of stay a straight line for a little bit and then break up. And the way that we could do that is using age to add noise. So we could do another pop flop maybe. Let's do another one so it just keeps it simple. So what are we going to do? Let's just put a turbulent noise down here, or yeah, let's use turbulent noise for starters. We might want to use curl noise, but we're going to take age and life and divide them, so we get a normalized age. So age divided by life always gives a 0 to 1 value, and then I'm going to plug P into pos for turbulent noise. I'm going to add that turbulent noise. I'm just going to add it to P, so it's not affecting velocity, it's not affecting force, it's just going to directly add to P. It's going to be 3D noise, and the amplitude is going to be really small. So it's just a little bit. There we go. Frequency, let's take that right up. Aha, there we go. And we'll make that original Perlin. Frequency, keep going, keep going. Alright, let's try that. So 0.01, let's say. Let's turn that on and off. There we go. So it's still quite large, so I'll just a little bit more. That's a little bit better. Now I'm going to multiply this turbulent noise by the normalized age, but first I'm going to run that through a ramp. So ramp, that. This is going to be a spline ramp. Plug that in there. I'm also going to plug that into color so that I can see what that looks like. At the moment it's black because our ramp defaults to this. But we should see, if I do that, let's go back. What we should see over time is that these go white. Although let's check out our life. Our life is 5. So actually what I'm going to do instead of normalized age is I'm going to create my own limit to life. So I'm actually just going to fit the age value myself. So instead of doing, 0 to 5, which is what we kind of have at the moment, let's do 0 to, I don't know, let's start by 0 to 1 and just see kind of what that gives me. So they should come out black, but then sort of start becoming white as they age. So you can see them getting whiter and whiter there. You could also limit this so that it sort of doesn't actually start until the particles are, maybe this noise gets applied between 0.5 and 1. So that the particles come out straight, but then as soon as they hit the age of 0.5 and to 1, they'll start getting that noise applied. So here you can see them getting white and getting that noise. I think 0.5 is probably too much. Let's try just 0.1. There you go. So they come out straight, and then as they age, they're getting this kind of more wiggly motion, or more wiggly position. Now we could just add this to velocity instead. So change that from P to V. So V, add and then adding to V, and see what that does for the effect. Because it will do something different. It won't be as noticeable. We might need to crank up the amplitude now because we're actually affecting V instead. So let's set it to 1, see what happens. Probably all gonna shoot away. There you go, so it's a little bit more noticeable. Let's make it 0.2. There we go. So we can see now that we're getting that kind of wiggly motion in there. And it's just helping to break that stuff up a little bit. Be a little bit more organic and a little bit less sort of streamy. But you can see it starts off as a nice stream, but then as it falls down, it breaks up, which is cool. It's a little bit weird on the ship like this, where it's kind of moving upwards and sideways as well, but I think we probably won't notice that too much. Yeah, this kind of backwards stuff is a little bit weird. But I guess this one here is kind of shooting that way anyway, which is a little bit odd. But anyway, I think it's okay. Should be fine. You can see it's made a big difference to the kind of overall appearance of that stuff. If we have a look at that versus that is very, very linear. And that now is, you know, a lot more broken up. Let's have a look at that overall. Maybe a combination of the two things might be good. Yes, you could apply the noise after caching the pop sim. It will be different. It will give you a different kind of result. If we were to do it, you know, let's say we've got a point VOP here, and we did the same thing, we could just go and copy that here, like this. Let's just copy all of this. Go out. Yeah, I mean, it's a good point. You definitely can do this stuff as a post-simulation thing, but it just will be different. It will give you a different kind of result. When you do it in the solver, it's going to kind of, I guess, give you, you know, an accumulation over the simulation, so it will evolve. But when you're doing it as a post thing, it's kind of, you know, it is going to be just a linear sort of, you know, it's either there or it's not, and it just doesn't change the overall simulation, which sometimes is good. You don't want to affect the, you know, overall shape or position. You just want to add a little bit of noise. It's kind of, yeah, you know, it just depends. Depends what you're kind of going for, I guess. Let's take this down. But it's a good point. It definitely is worth kind of exploring, you know, doing it as a post-simulation thing. So, yeah, we've got this ramp. We can sort of control where the noise is starting. You can kind of see up here. Maybe I should crank this up a little bit more. 0.1, let's go 0.2. So you can see up here, my ramp gives me the ability to control that along the length. So I can sort of have it, you know, start right at the top if I wanted to. I could do that, or I could have it just start much further down like that. I mean, it certainly gives you, you know, a lot of flexibility doing it as post, and we could do it as post as well. Or you could add like much larger noise. You know, if you take that frequency down, then it gives you the ability to kind of just do really broad noise, which is cool. You know, we could do that on top of that, so that we have these two kind of levels of noise where we've got this one doing a kind of larger scale effect. Yeah, either or, you know, it's kind of one or the other. They'll give you different results, but yeah, kind of. The other thing with you can see it happening here with the post noise. you can see how it's kind of looks like it's swimming through the noise a little bit, so you would need to maybe create an offset or run it, you know, off a different position value. Maybe an offset would be enough to kind of counter that animated offset, but yeah, you won't tend to get that with doing it in the pop sim, where you get that very obvious noise pattern replicating. But anyway, yeah, I think, you know, combination, it's good. We'll leave it there. Leave it on there. Just take it down, you know, a little bit. So let's just keep going with this one and see. Turn this back on. See what we've got. The other thing we could do is, you know, add a little bit of wind as well. It's all very kind of, you know, it's all very sort of straight up and down. So we could add a little bit of extra force or something to it. So maybe I'll just, whoops, I'll just duplicate this pop force here and just add a little bit of, what have we got, X. Let's try that. Probably going to be a little much, maybe. Oh, maybe not. I mean, we don't have wind anywhere else in our scene, so it's possibly not a great idea to do that, but... whoops. Just trying to find my scheduler. Maybe I closed it. Just wanted to see if that flip zoom was done. So, you know, there you go. There's some wind. So you could do something like that. You could also vary that. So turn on use vex expressions and randomize the magnitude, maybe. But here we've got this rand based on ID. I don't believe we created an ID. Let me see. We created PID here. So we got this PID, which we set up here based on the point number. So let's change that to PID, and then what we'll get is like random wind per stream instead of per particle. So that some will blow, you know, more than others. It's not gonna, some aren't gonna blow not at all because it's set to 0.5. So this is multiplying this value. So you can see then we get a little bit more variation, which is kind of interesting. You could also run this over age as well. So you could do like force times equals, let's do the same thing as we were doing in the VOP, where we put that fit, and we'll do fit at age between 0 and, I don't know, 1, let's say. And actually we'll start at 0.25. Let's go to 1.5, and then we'll do times equals 0 and 1. So rather than using NH, because the NH value, because the life expectancy is 5, I could take the life expectancy down, but because it's 5, it's actually quite long. So I'm just shortening that by using age. In a fit, I can sort of specify the range a little better. And this will mean that the wind won't be applied right at the start, but as these particles age, they will start to drift, which might be interesting, especially as it gets higher in the simulation or above the ocean. That might be kind of cool. You can see a little bit of that drift happening there. And I think we also have noise on this one, so I should probably turn that down. Or I could also, let's see, I could crank the swirl size up on that. It's always kind of handy to turn the guide on, just to have a look at, you know, what that swirl size actually looks like. Let's make it quite a bit bigger. And again, here we've got a fit based on age as well, between 0.1 and 0.25, but we could open that up to say, oh, I mean, sorry, that's not right. Between 0 and 1, so we could open that up and say, like, between 0.5 and 2, we're going to do something like that. Okay, so let's hit play and see what happens. So hopefully, as it ages, we'll start to see... I mean, it's going to be hard, because this stuff is falling and then dying straight away, so we may not see some of these things terribly clearly with the age-based stuff, because they might die before they get to that point, but some of them, especially the ones that are hitting the surface and staying on the surface of the ship for longer, they probably will get that, you know, get that force or get that noise. You can see it's getting quite noisy on the surface here. There we go. So let's have a look at that. So it's very kind of a lot more broken up now. I think I'm not sure I love how broken up it is on the ship, but let's see. Let's have a look at this, see how this is going. Version 2. Oh, looks like it's done. Oh, and look at that. Cool. It's hitting the edges of the collision shape, which is crazy. I don't know why it's... maybe my friction values are different. Cool shapes there. Kind of cool effect. Let's look at it with this. Be a bit easier to see. Hit the edge of the world. It's spreading a lot more than what we had previously, so I want to investigate what's going on there. But there's some interesting shapes happening at least. You know, it's not just this very kind of uniform thing. So let's have a look at that with everything combined. Oh, I guess my pops isn't quite there yet. Alright, so let's go and have a look at this. Oops. So on our ground plane we had bounce. So we didn't do anything there. And we have, yeah, nothing there. Let's take a look at this. We've got collisions. We've got stick on collision turned on, but it's not really doing a great job of it. We've got reseating off. Surface tension 100. I feel like that may be a little bit high. That surface tension. I might just turn that down a little bit. And what else? What else should I do here? Let's. Yeah, the other thing that I could do is give it a little bit of viscosity, because this is it's kind of foam, right? It's foam and bubbles and water. The stuff dripping off the ship is water, but you know, when it's on the surface of the ocean, maybe it becomes a little bit more foamy. So actually, let's do something interesting. Let's do a solver. So I'm going to do a SOP solver, and I will plug that into just the particle velocity tab. And then I've got my ocean water geo here, but I'm just going to go up here and call this water surface. And in the SOP solver, I'm going to object merge that. So I'm going to go // out water surface. There it is. Let's have a look at that. There we go. And I'm going to, let's see, do my old classic attribute transfer technique. So transfer to, transfer from. I'm actually going to scatter points on this surface as well, because it's a pretty large surface with not that many polygons. So, you know, there could be like 100 points in this location, but the point that I'm transferring from is only kind of on the edges. So by scattering points over the surface and even merging that with the, whoops, merging that with the original, merging that with the original object merge, it gives me like a much greater density of points. Because attribute transfer, I'm just going to be transferring from points to points. So the more points you have, the better chance, you know, or the better coverage you'll get. You can crank that right up. Probably doesn't need to be that dense. And then I'm going to put an attribute wrangle here and say at viscosity equals, let's say 10. It might be a little bit much, but let's see. Hi, I can't read your name because it looks like it's maybe in Korean, but hi. And I'm going to set here viscosity 0 on the stuff that's just coming in. But then when it's near the ground plane, actually I'm not going to do it on here. I need to do that outside. So let me do that here. Viscosity equals 0. And let's go viscosity equals 10, attribute transfer viscosity, and then we have a distance, right? So what we could do to visualize that is just make this a color, and this one a color, and then 10 is obviously going to be quite large, so that's 0 to 10 there, so that's massive for what we have. So let's do just 0.1. We could even do a blend instead. Alright, let's see what we get. And to make this faster, I'm going to turn off my collisions. So I should still be able to see it once it starts. And I will turn off my guide so that I should see if this is working. There's my pink ground plane, and here's my points. Why aren't they getting any pink? Should be. Oh, because I'm not transferring color. What a fool. Alright, so take that down, and yeah, let's do that. Blend width 0.1. That looks pretty good. You know, you could also give these particles an age, potentially, so that they don't do it until, you know, until they fall down again or something. Because they're basically, we're setting them to a viscosity of 10 as they get shot out. Maybe that's not what we want to do. And you can visualize that as well if you just create a marker for viscosity. We could see that on our points. We could see their values. So you can see they're not 10, but because we've got a blend on there, they're sort of anywhere between, you know, probably 10 and 0. So you can see I've got some that are 5 and 0, 3, 1, yeah, etc. So there's a mix. Maybe it'll be okay. Let's see what happens. I mean, 10 is not super high viscous, but it is, you know, it is going to have an effect. Let's have a look at this guy. This guy's erroring for some reason. It's just got a, looks like it's got an error baked in the network, so we'll just come back. Hopefully that will, oh, it's not plugged in. Turn this one off. There we go. Sometimes errors, you know, you just have to kind of click through them to get rid of them. They're not, it may have errored when I hit escape or I disconnected this, and then I need to reconnect it to make it go away, or click through the network in SOPs to make it go away. So let's see what it kind of does over time. Specifically when it falls back down and hits the surface, we want it to kind of not spread out as much. We could also put a pop drag down, and that will help as well. Yeah, you definitely get those errors, especially if you hit escape or, you know. Looks like it's just falling through the ground plane, which is, or through the collision, which is not amazing. Why is that? Ah, that's why. Because my effect relationship is left affects right, so this is coming in on the right, which means that it's not affecting it. Alright, let's see what this looks like. And so, yeah, you know, we had that problem of our collision, the simulation just hitting the edge and falling over. So we want to, you know, we definitely want to fix that. make it a bit larger. Hopefully slowing it down will maybe stop it getting to the edge. We don't want it to be a massive collision because it takes up more, you know, memory and it will make it slower. So you do want to make it as kind of as efficient as possible. So we should be able to see a kind of difference pretty quickly. Viscosity creates a kind of sticky kind of behavior with collisions, so it should, in theory, stick a bit more. Alright, so let's have a little comparison. We've got that, and we've got that. So yeah, already you can see that it's kind of clumping together a little more than what we had. So let's go and turn our ship back on, and then we'll go and hit save, save to disk again. There we go. So that last one took 28 minutes. Wasn't too bad. Now we can go back and, you know, talk about other things. I'll flick this back to version... Oh, actually, no, I'll just leave it. It's fine. So let's have a look at what we kind of have currently with our flip and our points. So this is our PopNet. Let's take a look at rendering for a little bit, just while that's caching to disk, and we'll see, you know, what this looks like when we actually render it out. Let's go back here to our PopNet. Yeah, it's writing to disk, Hardik. It's I can keep working now, and it's gonna just write that to disk in the background. It'll make everything else that I do in Houdini a little bit slower. As you can see, this PopNet's going a little bit slow now, but yeah, it'll write out. All right, let's jump out. Okay, so there's my spaceship that I need merged. So I didn't need that one coming in there. There we go. So let's take a look. We're going to need more out of our particles. I might just use the pop streamers for now just to talk about rendering. So I'm going to create a null here and say out particles. That'll be fine. And this one can be out flip. And then I'm going to create another geometry container, and I'm going to call that render particles. And this one can be render flip. Render particles, object merge. And here it is. So we've got our out particles. All right. So we don't have a particle scale, a p-scale attribute. So let's create one. Oops. Attribute wrangle at p-scale equals 0.001 for starters. Just make it small, because yeah, if it's really large, it'll render huge. So I'm going to render particles. I'm also going to put this material before my ship here, out ship. So this is going to be my water surface for rendering. This is going to be my ship container. So ship render. Oh no. Well, that's great. Let me just open a new one. What is good though is that my ship surfacing flip sim should keep going in the background, hopefully. So let me just open up a new one of these. And do fatal error. Okay. That's the other good thing about, you know, rendering a background is that it forces you to save before every time that you do that. So it, you know, you end up saving a bit more frequently. And we lost our render scheduler now, and if you open up a new one, like if I open up render scheduler, that job is not there, but you can see, or maybe it did crash it. No, that's not good. I thought it wouldn't do that, but maybe it did. Maybe it did. Oh no, there it is. H-batch. Still running. Great success. Okay. So, let's just save this back to the correct location, which is where? Stream. Spaceship's Rising 6. There we go. Alright, so we've got our ship. So I'll call this render ship. And object merge. I don't know what my memory is doing, let's check. Oh, it's fine. It's plenty of memory. Yeah, that's right. The emotional roller coaster that is crashing in 3D. Alright, so let's choose our water, our ship. There it is. We've got our water here. Okay. Let's get ready. So we've got our mantra node. I'm just going to call this test. We've got objects. We don't have any objects. We've just got a star and candidate. So that means that it's going to render anything that's visible. I'm actually just going to do this. I'm going to do star render star. And that will just wildcard anything that has the word render in it at any point, because I've got a star in the front and at the end. So anything that's called render now is going to render. So it's going to render the flip as well. I don't have anything in the flip there, so I'm just going to turn that off. It's also in the candidate objects, which means it's still going to respect the view flag. So that's good. Alright, let's hit save and go to our render view, turn off progressive. That's right. It would be an awful elevator if it, you know, suddenly dropped and then rose again. Alright, let's see what we get. This, because I am simulating the background, you know, this potentially could be slow. Wow, look at that. So there's our ship. And I can see some particles there, but I don't have any water. And that would be because I don't have render in here. Oops. Render. And watch what happens. Hey, look at that. Now it's a bit more mysterious. Okay, so let's just hit stop and we'll go and find a frame that looks good. Towards the end. Let's just do the last frame maybe. So our water, still very low detail, but that's okay. We're going to work on that. Looks like our H-batch is still running. Cool ship model. I put the link to the ship in the description this week, and also in the comments last week. Someone asked for it, so you can go and buy it if you want. It's pretty cheap. I think it's like permanently half price, so it's, I don't know, it's not very much, $20 or something. All right, render particles. Let's take this up by one. And there we go, we can see those now. Great. So these probably don't need a fluid surface on them because they are just very thin streams, and the distance we are from camera, you know, this should work fine. Now let's have a look at what attributes we have. We have ID, we have PID, so we could randomize based on both of those things. First of all, we could do this. We could do, let's do fit. Actually, what am I going to do? Fit 01 rand at PID between 0.05 and 0.01. So that's going to return a random result based on the PID, and each stream has a unique PID. So it's going to give each stream a different size. Rather than every particle a different size, it's going to give each stream... So some streams will look larger than others. Rather than just varying the p-scale over everything, it's just going to give an interesting kind of, you know, scale to all the different streams. Maybe that 005 is... Oops, that one there is too low. 01, not 001. There we go, that's a little better. So we also have a really low particle sample at the moment, or sorry, pixel samples, which means that, you know, some of the really fine particles are probably not getting caught at the moment, which is why it's looking a little bit sparse in areas. But you can see that randomization already has helped just make it feel a little bit more organic. We've still got the color on there as well from our visualization, so let's just put a color node down. And there is also no material on this at the moment. It's just getting the default diffuse shader. So there we go. Now you got to remember that there's also flip on top of this, so this intersection with the ground I'm not really concerned about. Let's give it a shader now. Go to our material context, and what will I do? I will create a principled shader, and I'll call this one pop streams. Set it to white, and I guess I'll leave reflectivity on for starters. Let's just see /matte/pop streams. There we go. We can see it's a little bit brighter now as well, which is great. So we could play around with this. We could give it transparency. I probably wouldn't, but we could try it and see what it looks like. The problem with transparency is, one, it's going to make it slower to render. Two, it makes it disappear a little bit, and I want this to kind of be quite present. I mean, it does give it that kind of watery look, but, you know, maybe I don't necessarily want that. Maybe I want it to be a bit more bright, foamy looking. I don't know. It's not too bad. You can also turn off under opacity or turn on fake caustics, and that will stop any shadowing that you might get, and you'll see some of these parts in the shadows get a little bit brighter. Transparency just takes time to calculate because it's, well, refraction, so it's passing light rays through the object, and then it has to calculate what's behind it and show it up in the object. Whereas if it was just reflection or just diffuse, the light ray hits the surface and stops or bounces off. But when it passes through, that's an extra calculation that it has to kind of work out, and then, you know, where that light ray then ends up on the other side. And you have this index of refraction, so the light ray comes in and then bends and then shoots off somewhere else. So it's just all about extra kind of calculations. It's not load. In this case, it's not loads longer, but I mean, it will make an impact on the render time. We still have very default set or low settings on our render, so it's not, you know, it's not that bad. We can try, like, if you look at this, 48 seconds for a render, and then turn off transparency and see, you know, kind of what that gives us. It might not be that bad at this, you know, at this sampling and this resolution, and for this particular object. But yeah, there's just things to think about when you're rendering this stuff. Do I need that? Is it important? if it's something that you do need, then, you know, of course, you just have to deal with it. But my goal is always to reduce the render time. So, well, there you go. You can see it's, what, 17 seconds faster without transparency. And, you know, I mean, there are nice things about the transparency as well, but I don't think we really need it. I'm going to go down the bottom here and turn my mission color to white. And this now should show up really bright. There we go, super bright. So if I'm going for like that kind of really bright foam look, then we'll use some emission. This is too much, but it's good to have it on there because it gives it that feeling of, you know, light scattering in and around, like bubbles. They get very bright, not this bright, so we'll turn it down. Let's make it 0.1. But overall, it will just give it a nice lift and make it very, you know, sort of present, easy to see. There we go. We could also give it, I mean, I think increasing roughness will increase noise, but it may also increase kind of glints that we get from the reflectivity, just so that the particles become quite, you know, just, they'll give little sparkles and little glints and highlights from the lights if we increase the roughness. Alright, it's not looking too bad. I'm just going to go to my out context here, and I'm going to put in the matte slot the water. And that will just get rid of the water, so I can just see it on black. Also, actually, no, that's okay. I just want to see what it looks like without the water there, so I can appreciate the details. And then I'm going to go and increase my pixel samples, because I want to see, you know, you can see how these streams get a lot kind of firmer, and, you know, we can seal them a lot sharper. Now this is our old sim, don't forget, so it's all very linear. But you can see all this stuff just gets all nice and solid now. So that's why I wanted to turn off the water, just because this area will take a long time to render. There we go. So these sparse points are still pretty sparse, so that pixel samples aren't going to fix that, but you can see overall it has made the water really crisp, which actually makes it look worse. I think it actually looked a bit more watery when it was like that. Now the other thing that we can do is we've got our randomization per PID, but now we can also add randomization. So let's do times equals, and then fit01 rand at ID. And then we'll just times by 0.5 and maybe 1.2. And so that is going to have a random ID per stream, but now also a random ID per particle as well. So we've got two levels of control there for the particle scale. And you can see the random ID per particle has broken up that very, I didn't snapshot it, the other one, but snapshot that. It's broken up that very uniform line now. We can, you know, we can take it down more to get more variation there. Even maybe that, just leave that at 1. What is fit? So fit is basically like a way to take a value and change the range that that value is running between. So with random, for example, random always outputs a 0 to 1 value. So I wish I had a like a whiteboard here. Let's see what I have. Use Microsoft Paint. Let's see. Here we go. So when you have, you know, a range like random, so random produces a value between 0 and 1, right? So you got this range. Look at that. Straight line for a mouse. So 0 to 1. With a fit, what you can do is go, well, my value that was 0, let's say maybe I want it to be between 1 and 20. Like that. So what your expression would look like is, you know, fit let's just say rand, well, now I'm testing my mouse skills, rand at ID between 0 and 1. So this is the old range, these first ones. And then the new range is 1 and 20. So what was 0 now becomes 1. And what was 1 now becomes 20. And everything in between becomes the values that are in between 1 and 20. So, you know, if we start with 0.5, that becomes halfway between 1 and 20. If I started this at 0, it would have been 10, but it's now like, I don't know, 10.5 or 11 or, yeah, whatever. Let's say 10.5. So it's just a straight kind of interpolation of what these values were before, like that, and 0.75, into the same kind of fractions between that new range. So it's just a straight kind of interpolation of what was 0 to 1 now becomes 1 to 20, and everything in between gets assigned those values in between. So I don't know, you know, what this would be, but let's just say it's 5, and let's say this one's 15. So does that make sense? It's just a way to take a value and its range, or a range that you kind of decide on, and then give it a new range for various purposes. And in this kind of application, I'm just taking a 0 to 1 value and saying that the values, what was 0 is now 0.3, and what was 1 is 1. So I'm just basically changing that. Fit 01 is just a shorthand way of saying, I know that this value that I'm creating here is between 0 and 1, so I don't have to do the old min and max. This assumes that the old min and max were 0 to 1. So it takes this section out of the code and just allows you to do this section. Cool, great. Alright, so yeah, you know, that I think has definitely helped. It's given us back that kind of speckly, watery look. So I like that. I think that's cool. Alright, I think our simulation should probably be done now. Our flip's in. So let's take a look at that. Still falling off the edge. Is it done? Let's have a look. Let's check our timestamps. Alright, so we've got 10:55, 11:15. Oh, it hasn't quite finished. It's at 237. But it looks basically the same. Wonderful. That's odd. I would have thought that would have, you know, made some sort of difference. This behavior here is a little bit weird that I'm seeing, and I think that might be down to the surface tension. You see how, like, the particles get very ordered? They get very kind of spaced out and perfectly sort of, yeah, like that. I think that is being caused by the surface tension. So I'm going to have a look at that. Previously in like Houdini, I don't know, 18 or 17.5, I can't remember, the surface tension values used to be really, really high, but they changed something with the math for the surface tension calculation. And the values now seem to be very low. So that looks like the default 10. I was going to do revert to defaults, but it's grayed out, which means that is the default. Also, actually that didn't go bold, although the number went bold. You can see, so the way that I figure out whether I have changed something from the default or whether someone has changed something if I'm looking at a student file is the values or the labels are bold. So you can see enable surface tension is bold, which means that is not the default. That is the default. If I set this to 20, you can see now that number goes bold. So that is not the default. You can always right click, revert to defaults, or control middle click. But that's how I tell at a glance, you know, whether something is the default or not. So let's try 10 and see, you know, see what that looks like. I'm just gonna do it again. Save to disk. Let it run. We can use this simulation anyway for you know, for rendering, but I do want to kind of improve that. You know, this is really weird to me. And yeah, I definitely want to improve that, like spilling over the edge. It's not great. Actually, what I'll do, I'll just kill this, and before I set that off again, I'm just going to add a pop drag as well. Add a little bit of drag in here. 0.1. Let's try that. Alright. Save to disk. Okay. So, let's go and have a look. So we've got our flip. Let's go and have a look at our flip. Maybe something like this. So we've got our flip. Any particles there? Yeah, there's a few particles there as well. So we'll turn on our render flip, and this one actually doesn't have anything in it. So let's just copy... I might copy all of this, paste it in my render flip, and say out flip. There we go. So we've got our... We don't have PID on this on our flip particles. Our flip actually does have a P scale, so we could use that. We've got to just check and see what that P scale is. It's 0.12, so it's pretty large. So let's get rid of that. We've got P scale times equals fit01, and we do have ID, which is good. So let's do between 0.05 and 0.00. Well, let's do 0.1. Let's give that a go. We'll give that the same pop streams material for starters. But then we'll probably mesh this, or maybe do something else with it. So let's see what that looks like. I might just turn off my environment light for starters as well. Whoa, render water, turn you off. What am I seeing here? What is that? I wonder if that is the surface volume rendering out. Let me blast that out. It looks like a volume there. I'm just going to get rid of that. I'm going to choose stream volume source and then delete non-selected. And that should, oops, there we go. That gets rid of those volumes that were present. Render view. When you do a particle fluid surface, those things go away, but because we haven't done that yet, maybe, you know, that surface volume is rendering, which is weird. Hey, there we go. Alright, so it's pretty sparse. Let's take this. Let's go 0.1. Let's see what that looks like for our particles. There we go. Alright, so we'll go maybe 0.08 to 0.12. 0.12 was what it had. We could also just turn this off and see what it looks like with the P scale that comes out of flip. It's going to be really fat though. You can see they're like giant balls. And that's because we've rendered it as, or we simulated at a pretty low resolution. So, 0.1. Stop. Oh, I turned it off. That's why. I was wondering why it didn't update, but it was off. Okay. Try again. I just got this error pop up which says that it's unable to open the file Spaceship Rising 137. BGO. This is a temporary file that's trying to open, a render file. So sometimes when you get that, like mantra error like that, you just hit stop and render again, and it will force it to rewrite out that temporary render file. It's basically like the whole scene it creates as a temp file before it renders. So sometimes that can error if you're making lots of changes, because this is an auto-updating thing, it can just freak out. Sometimes you just might need to remove it. Alright, so there we go. Here's these really even particles, which are ugly, but looks pretty cool around here. I mean, we could also potentially have this stuff die off as well. You can give particles in flip an age, which you don't often tend to use to kill things out. But if we're treating this like foam bubbles, yeah, maybe they get created and then they die. So we could control that via an age if we wanted to. That would be, quite handy to have that. Let's turn on our water and see what this looks like on the water surface. We actually have that in the matte slot, so I'll need to remove that. Looks like we have a little offset here. Probably because our collision resolution is a little bit lower resolution than what we need, so we've got a little offset, which is interesting. Not too hard to fix, but yeah. Easiest way to fix that would just be to create a little offset on our water. Hey, Richard. Yes, that's right. I am doing a kind of, a cheap flip simulation where I don't have the whole tank, and I'm using the ocean surface, or the ocean spectrum geometry as a collider. That's right. Well, there we go, getting closer. So I'm just rising this up a little bit. I mean, ultimately, I will simulate at a higher resolution, so this offset might be less of an issue. It's also probably a reflection or something going on there. But yeah, it's it's okay. It's not too bad. This probably isn't going to be the final kind of look anyway. Just kind of playing around. Just want to see what it kind of looks like. And yeah, so this, Richard, this is the setup that I have at the moment, which is the ocean spectrum into the ocean evaluate, coming off a grid. The grid is reasonably low resolution. And I should probably do this transform after this, because this is actually feeding into the simulation. So I might do that down here. And then, yeah, in the flip, I have, so in this network, I have the water surface being extruded, turned into a VDB, and reading that in as a static object for the flip sim. Alright. We don't have motion blur on as well, which actually will make these particles look better. So, we do have velocity attribute on these particles. So let's go here, sampling velocity blur, out, rendering, enable motion blur. And that will just smear these. Not tons, but it will make them feel a bit more, watery and less, there we go, less like little balls all over the surface of the water. You can see that it actually, it just helps to soften the effect and gives it that feeling of motion as well, which is really nice. Especially on this kind of, on the streaming down sort of particles, it will help those streams feel a bit nicer. Just have that feeling of directionality. And yeah, on the surface, these look pretty awful as little dots, so motion blur is definitely going to help that. We definitely want to work on this. The offset here, these little black dots are the reflection of the shadows. There we go, that looks cool there. So you can see our render times are certainly going up, you know, especially with everything visible. But the way that I would approach rendering this is to not render this all together. So I would render my particles separately. And that, you know, hopefully will make that pass go quite quickly. I can have specific settings just for the particles, and then I'll render my ship and my water separately as well, and then composite it all together in Nuke at the end. And we can look at doing that too. Obviously I can't render this out over the stream, the entire thing, so I'll render it out during the week. Probably, I don't know if I'll do it this week because there's still a bit to do, but we will get to that point. So there, I mean, you can see motion blur has helped a lot in just making it feel a bit nicer. I mean, our ocean needs work as well. That's, you know, that's definitely something that we need to work on. And this just has a principled shader on it at the moment. Actually, it's not too bad, you know. But quite often, what I will do with, you know, with a fog like this is I'll create a, oh sorry, not a fog, with a foam. I'll create a fog, a volume shader. So I'll do a volume shader core. That. And I'll do a compute lighting node. So plug layer into layer, CF, OF, and F. And then I'm going to bind density into here. And I'll have to do some work in SOPs to get this working. But now I have a volume shader, a very simple one. I'm going to call this foam volume. And I think I probably did this on the wave tutorial or wave streams a little while back as well. But I'm going to take my flip. I might just duplicate this and I'll say render flip foam, like that. And let's do a VDB from particles. Set my point radius scale to 0, set my point radius scale to 1, minimum radius to 0, and then my voxel size, you know, needs to come down quite a bit. I'm going to make it a density volume. It's there, you can't see it. Make it dark. There it is. So we can adjust the point radius scale here to make it a bit larger if we want to. But let's just see what this looks like. So I'm going to go out. I'm just going to duplicate this test and call this foam. And then I can just choose which one I want to render. So flip foam. And force matte, I'm going to choose the ship and the water, I guess. We'll put those in there. And then render that one. Foam. See, actually, one more thing. I need to give this the flip, foam volume, that's what I called it. Yeah, alright, let's see what that looks like. And there we go. So it's very kind of light at the moment. Let's crank up the density. There we go. It's looking a bit better. Let's also take the shadow density down. Make it a bit brighter. And we can also add emission. I think we can do that. Let's see. We don't have smoke brightness on this one. So one thing that sometimes I will use instead is the pyro shader core. And that actually has a smoke brightness. So we can try that instead. Density. Let's go smoke brightness 10. There you go. So you get that kind of brightness. But this doesn't have a density scale, which is weird. So you have to multiply the density with a constant. Let's do that. 10. There we go. So that makes it nice and dense. That's our color, that's our alpha. So let's take that brightness down a little bit. 2. We also have shadow density, so we can take that down as well. Alright, so let's see what that looks like. What am I going to do? Render flip, got my render flip foam. I'm going to just hide my render flip, render the test, and this should render because it's a wildcard render node. It should render the foam instead of the flip because the flip is turned off. Let's see. So because this is a foam volume, it's a little bit softer on the edges. It's not hard edged. It might just blend into things a little nicer. You can do it as a combination as well. It doesn't have to be one or the other. You could have both. We might try also turning this into a particle fluid surface, rendering that. That might be interesting as well. But you can see, we've got these particle streams, but now we have this kind of foamy volume over the top. It's probably a little low res and the particle size is a little bit large. But you can see it has a different feeling to, this kind of look. Also, we've lost our velocity because we've done a VDB and we've created density, but we've lost that velocity. And now we've got volume. We should create, I'll just turn off auto update. We should create a VDB, we'll call it vel. And it's a velocity type. So now we have a vel field, which is a vector 3. It stores our velocity information, and our density field. So now if I was to just stop that, take a snapshot, hit render again, we should see we get our velocity smearing back. Let's see what happens. You can do it. There we go. Look at that. There's our velocity smearing back. Alright, so definitely, we want more resolution out of this. So let's go down to, actually, let's take our point radius down and let's make our voxel size 0.25 or 0.25. That's what we had on the ship as well. Hopefully that'll kind of be alright. And I mean, we don't have a super dense amount of points, so it is going to be a bit sparse. Because our simulation is a little bit low resolution. With a higher res simulation, probably be better. But we could have a combination of things. So here's our foam, and then we could turn our flip on as well, so that we have both of those things running. And then potentially we could scale our flip down. I'm just going to create a multiplier here, so at p-scale times equals, let's just do 0.75, take it down by 25%. Maybe even more, 0.5. So we've got these really fine particles, and then over the top of that we've also got, this dense foam volume. So it's just going to kind of soften everything. At this resolution, it sort of, it's sort of hard to see. Having velocity effects to look even without motion blur? No, motion blur is turned on, Mateo. So I've got geometry velocity blur already turned on from when I was doing the flip particles. So I just needed that velocity field to get that motion blur back. And it's turned on in Mantra as well. There. So it won't affect the actual volume at all. It's only a render time thing. So you can see, we're just softening that down a little bit, that effect. It's not this sort of hard edge thing that we're getting there. It's a little bit more transparent and a little bit softer. Overall, just needs to be way more dense in terms of the amount of points, so that more points you have, the smaller you can go with the point size. And for this scale of effect and shot, it's It's meant to be a large ship surfacing. We do want that P scale really small, otherwise the scale can look a bit wrong. If those particles are too big, it'll make it feel like it's a much smaller ship, and we don't want that. So overall, if this was much more dense, it would, you know, it would feel better. But that's starting to, you know, starting to soften and starting to look a little bit nicer. Now let's try the other thing I was talking about, which was to take, you can see what that looks like in the viewport. It's a little bit different to what it looks like in the render. Let's take this here and do a particle fluid surface on it. So it's going to turn into a volume, or, you know, a mesh. Turns it into a volume first and then a mesh. Particle separation. Our particle separation was 0.1, I think. Let's check. It's actually, our grid size is 0.2. The grid size is 2 times the particle separation. So yes, our particle separation was 0.1. Let's take some of these settings down. Droplet scale. Influence scale. There we go. Maybe even, you can, of course, make the particle separation whatever you want. And that will just increase the kind of, it will increase the detail of the underlying VDB that's being created. So you will get just more detail. And a higher resolution mesh. Let's take our adaptivity down a little bit because we're trying to get some smaller kind of points. So you can see, you know, compared to that, we've got now, if that was a volume, surface VDB, and then I'll do a convert VDB and turn it into a density. So VDB class, SDF to fog. Now I've got that as a fog volume, and it's going to be, you know, if I get rid of that, doesn't matter. It's going to be a lot more dense. So let's render that and see how that looks. It's going to make it sort of more cohesive. It's going to be less of this really pointily sort of look and just more of a blobby volume. Which, I don't know, maybe a combination again of the two things might kind of work well. You don't want it to be too kind of intense and blobby. Let's see, what do we got going on here? Convert VDB, render flip foam. I'm just going to turn off these things so we can just hopefully see it. And it's called surface, so we need to put a name slot down and change the name of that because our volume is called density that we're calling in our material. And there we go, there's another IFD error, render file error. So we'll just hit stop and render, it'll recalculate. So I'm just there putting the surface name. So here we've got surface, and I'm changing it to density. Just renaming that. And then because our shader is calling density, it didn't know what surface was, so it just creates nothing. There we go. So you can see it's a much sort of thicker, more cohesive foam element. Doesn't look as good, but it's an interesting kind of thing that you could try. Let's flick it back to surface polygons and see, you know, if we can make this a little better. Let's add some smoothing. Maybe double smoothing. Let's turn everything on, see what happens. Some interesting shapes there. Let's take this down a little further. Okay, cool. Alright, let's output surface VDB again. And we could combine these two things as well. You know, you could just do a VDB combine here. And set to copy at the moment, we could just set it to add. That will add the two densities together, hopefully, although we do have a vector 3 field in here as well, which makes it a little bit problematic. It's probably easier to just Actually, yeah, we could just merge these. I think that will probably work as well. Let's have a look. Might just hit save. Hard to see if that other one is rendering. Sometimes when you merge volumes together, it might just only render the like the leftmost one in the merge. So I'm not totally sure that it is rendering this one. Let's just flick it to that and see if we can see a difference here. There you go. See, now you can see that that one appears. That's why it's not a good... Sometimes it works, but possibly because we have different resolutions, it's probably doesn't like that. So what I'm going to do is just stop this. I'm going to duplicate this render flip foam. I'm going to call it, I don't know, flip foam B. And I'm just going to render that stream, so I'll have that one not there in this node. Like that. And then we've got two. So we can render this side and this side. And then they'll render together. So quite often when you have multiple volumes that you want to render together, it's good to either try and combine them using a VDB combine, but if that doesn't work, split them out to different objects. Like if you've got different fires next to each other, or a whole bunch of different fires, it kind of works better, I find, as actual different render objects. So now we should see, yeah, you can see the spotty ones there and this one. Now if I go back to my out context to my test here, I've got pixel samples of 2. If I take that down to pixel samples of 1 again, I should get a much faster render. It's very noisy, but I can come down here to my stochastic samples and just up that. And that should improve. You can see how that has improved the fidelity of the volume, but the render is still pretty quick. So you can chuck that up even higher. The other thing with volumes is take the volume quality and shadow step rate down, and you won't really see much of a difference. Shadow step rate, you will see more of a difference, but volume quality, you can take that right down and you won't see any change there until you take it really, really low, but you can take it really quite low. So, you know, it's kind of an interesting look, this smoothed out foam. It's very foamy looking. Probably a little bit too soft, but I think it's kind of cool, you know? It's a nice element to have on there. The problem with particle fluid surface is that it can be a bit flickery, so you would really have to test it in motion. Let's get our water back and just see how that looks on the surface of the water as well. You would really have to test it in motion just to see kind of, you know, what it looks like overall. Also probably don't want it to cast shadows, so may want to just turn that off. So yeah, it's a little bit kind of intense maybe. What I might do here is, just going to turn off auto update, duplicate this, call this foam volume B, apply that, and I'm going to reduce that density on that one. So foam volume B. There we go. Yeah, it's not too bad, but it's a bit too thick. And I think, you know, when we do a higher resolution, or when I do the higher resolution simulation, this should just tighten up and not become so blobby, and just hopefully we can make it much tighter and much nicer. But anyway, there's a bit lower density, which is kind of good. But yeah, it's too blobby, I'm feeling. We can potentially try and adjust it in here. Just by taking, you know, we can continue to take the droplet scale down. And also the particle separation. This sometimes can be a kind of hard way to create the effect that you want with the VDB as well. So you could just do a VDB from particles, like I was doing with the other one, and then just control it like this. So, you know, it's very easy to just take the scale down. We can go 0.2, take the voxel size down, and then you can do the same thing. So VDB smooth SDF is the one that's being used there, set to, oops, set to mean curvature flow is the one that's being used in the particle fluid surface there. So you could set that yourself, then when you convert that to a fog, you know, you can get a much finer resolution that way. And sometimes it's a good idea to convert it to polygons just to see kind of what that looks like as a mesh. Makes it a little bit clearer. So you can see I've got that. So I've got a really fine and small amount of particles then, and then the smooth is just kind of giving me that kind of result. Yeah, that's right, Richard. It has got a lot in it, and it can. I find when you have a high-res simulation, it's not too bad because just your simulation looks pretty good anyway. But there's a lot of stuff going on in here, and I do find it is just sometimes it's because everything's sort of balanced against each other. So it's not just one setting; it's all the different settings, influence scale, droplet scale, all that stuff. So it just makes it way harder to go, well, I just want smaller blobs, you know. Whereas this just allows me to go, this is my resolution, this is my scale, that's it. Then I can do whatever I like on top of that. So that's not too bad. We could continue to drop that resolution and get even higher res. Then we smooth. Yeah, so we go from that to that. So it's much higher sort of fidelity. Got our flip foam. Alright, let's have a look at that. How long will it take to render this final animation? It's a good question, Stephen. I mean, like I said earlier, I won't be rendering it all in one pass, and that should speed things up. But if I look at my ETA here, I mean, this is very low samples. So we're looking at, I don't know, it could be 3 minutes a frame or something, 4 minutes a frame on this at the moment. It'll take a while. It'll take a while to render. It'll probably, probably just be an overnight thing, I would hope. It may take 5 or 6, 8 hours if I'm lucky. I could render this in Redshift as well, and that would improve, render time significantly. So let's turn all this stuff off. I mean, my goal is always, as I keep harping on about, my goal is to always make things render as quickly as possible. So I will definitely be trying to get my render times down as much as I can. And you can see, when I don't have the water in there, yeah, it goes pretty quick. Renders in 14 seconds. So by splitting it up, I can get passes out very quickly. And it means that if I need to change something in the foam, for instance, I just re-render the foam, and it's a very quick render. But if I have to render everything every time I want to change something, it just, it will become a nightmare. So there we go. That foam is feeling a little better. And I can just, I can go and adjust things like my smooth to see, how that affects the way it appears. You can see the smooth definitely reduces a lot of those much smaller points that are there. Maybe that's a good thing. Maybe it's a bad thing. We could go and go back to our material and try increasing that density now that we've got a much sort of tighter foam volume. let's check out the resolution of that as well and just see what we're dealing with here. It's only 1 million voxels, so it's actually, you know, it's not that bad. We could, let's, I might regret, you know, increasing this voxel size, but I will just get higher fidelity out of this thing. Let's go 0.1. My memory, you know, I'm still around 33 gig of memory, so should be fine. You can see the fidelity I'm getting out of this volume now. So I don't love these little dots. I'm hoping to get rid of that in my simulation, but let's just increase our smoothing, and that will hopefully smooth those away. Not entirely. Because we have a higher resolution simulation now, the smoothing has less of an effect. So that's something to consider. Where is part of this video? Do you mean where is part 1? Part 1, there is a link to part 1 in the description. There should be, at least. But if you go to the CG Spectrum website, or not website, sorry, the CG Spectrum page in YouTube, then you'll be able to see a playlist of all the VFX or Houdini tutorials. And yeah, you should like and subscribe as well, and then you'll get notified of all the new ones. I think we're up to like 24 or something. Is that what I called this video? Or I said part something. I think, yeah, this is version 24 or 22 or something. I can't remember. I've done quite a few now. So you can see that's looking a lot better. It's looking a lot nicer. Let's get our water back. So lots of work to be done still, but you know, that's not too bad as a foam volume. I'm pretty happy with that. And we turn our particle streams back on as well to get that extra sort of fine detail in there. You can see on there. Again, particle pixel samples of 1. VFX title series is completed. Yeah, well, yeah, I mean, I sort of, I guess I didn't finish it off as much as, you know, what I would ordinarily, but yes, it's there. Yeah, if you want to watch it, it's all there. Flip. Let's turn the flip on. There we go. I mean, yeah, for anyone new that, you know, hasn't been watching, you know, the whole time or missed things that I've said, these aren't designed to be, you know, tutorials. They're not. I'm not going to tell you every single thing to do, although you're seeing me do it, so you can follow along. But you know, it's an opportunity for me to talk about the way that I work and the way that I would do things. And you're more than welcome to ask questions while I'm doing it. But, you know, these aren't designed to be in-depth tutorials. More just sort of, yeah, watching me work on how I do these things. But if you ever have any questions about something or something you tried wasn't working, please let me know. I'm very open to that. But, yeah, we do offer a full course at CG Spectrum of how to do this stuff, so you know, these are not designed to replace that, I guess. Alright, so I think that's looking pretty cool. You know, the fidelity out of that volume is looking really nice. Let's see, we've got no velocity on this one, so let's do that too. We need our particle volume, point attributes. Let me just stop that render. Let's go V, and we'll call that Vel. Thanks, Audrey. That's erroring because... Let's see, maybe it errored because I hit escape. There we go. It's skipping velocity, but that's okay. Convert BDB. I'm just going to convert the surface field to a fog. There we go. And that one is just going to rename the surface field. So now we've got vel and density. Let's go to our out context and just, you know, for the last 3 minutes, it'll probably take longer than 3 minutes, but I'll just put my pixel samples up. And I guess I'll turn my environment light back on so I don't have black in the background, and hit render on that. And we'll see at the, you know, slightly better resolution, slightly better pixel samples, what, you know, what it looks like. Did I learn any coding language for this software? Yes, yeah. So Vex is the main sort of internal coding language that we use with Houdini. I don't use it all the time, as you can see. I haven't really used any today. A little bit, actually, but not much. But it's not, you know, it's not a super requirement of being able to use Houdini. It definitely helps knowing it, and you can do a lot more and be a lot more efficient with the things that you do if you learn Vex. But it's, yeah, I mean, I'm not a super technical Houdini artist. I'm more focused on the visual side of it, the artistic side. It's certainly very handy to know Vex and to be able to do certain things in Vex. As you can see, the things that I do, they're usually pretty simple, but it does mean that, you know, I can do them faster. But that's the good thing about Houdini, is that there are just lots of different ways of doing the same thing. So if you're not particularly code inclined, then you don't need to. You can use FOPs, learn to do coding visually. There's lots of places, you know, to start. I would recommend just going to the Side Effects website and looking at their sort of getting started tutorials. But, you know, we also offer an introduction course at CG Spectrum, so you can take a look at that. There are links in the description for that, where we would take you through the full, you know, sort of package, from learning the basics to learning some more complex things. It's an introduction course. It's only 12 weeks, so it's not a comprehensive course, but we also offer that as well as part of our diploma. So yeah, but, you know, I would just, if you're very, very new to it, I would just start having a look at the getting started videos on the Side Effects forum, and keep watching the streams, and, you know, keep asking questions, and I'll try and help you. You definitely, you know, it's definitely a challenge to learn, but it's not impossible. And there's lots of people out there that, you know, providing good insight and good kind of knowledge. There we go. So we're starting to see, hey, no worries. We're starting to see a lot more detail now with the pixel samples at 3 and 3. So, yeah, I mean, our ocean definitely lets this down. There's not a lot of detail in this ocean, so that kind of is something we'll need to work on. But I'm pretty happy with how this is looking. I think I'll render this out over the week, and we'll see how long it takes. As you can see, we're looking like, I don't know what we're approaching. It's going to be about 3 minutes for this, per frame, that is. Let's, should I learn to use, no. I mean, that is something that students, you know, students that I have quite often think that they need to learn every aspect of every node of Houdini and every kind of facet of it. It's, you know, you just take it step by step and just learn one thing at a time. I find also it's easier to learn when you have a goal. So let's say your goal is to create this effect, then you learn the things that you need to create a ship rising out of the water. So particles, collisions, flip, rendering. I haven't learned, you know, vellum or rigid body dynamics or any of that stuff. I'm not worrying about that at the moment. I'm just worrying about focusing on flip. And by having a goal, it allows you to kind of know where to search and what to kind of search out. So I'm trying to do this effect, and then you start Googling, you know, all these different things. Or if you're looking at particles, you start looking at tutorials for particles, and just do it like that. Instead of just going, I need to learn every single node and what it does and what it means. I don't. There are lots of nodes in Houdini that I don't use. It's not, you know, that part of it is not for me. There are lots of modeling nodes that I don't use. There are lots of animation nodes that I don't use. Crowds, I don't really do anything with crowds. So, yeah, there's a whole world of Houdini that I don't care about, and it doesn't affect me. It's far more important to learn the basics and the fundamentals of how Houdini works, and then everything in Houdini works the same way, basically. So once you learn fundamentally how Houdini's working, you can just take that. You know, I could go and start making a crowd if I wanted to. I'd have to figure out, you know, which nodes do what and how, like, what parameters they use. But because I know how Houdini works in general, it won't take me forever, or it won't be very hard for me to figure that out. So, fundamentals. Focus on your fundamentals. But have a goal as well, because it really helps. Alright, so let's see. What was I going to do? Oh, just lastly, because I do have to go, but I was going to check out this simulation and see what it was looking like, because it kind of looks the same here. And as you can see, it's flowing off the edge again. I guess it's flowing off a little less, maybe. We've got that drag in there, but yeah, it's not amazing. So I'm going to have a little bit of a play with it this week, and I'll be sure to write down everything that I did so I can tell you. But I'm just going to have a quick play, just because it takes so long. It'd be great if I could get this into a good spot for next week so we can focus on other things. I want to investigate what is going on here with this stuff. I might just run it at a higher resolution and see if that fixes it. But I want to investigate what's going on with these points doing this. I think it's probably surface tension, but I'll just do some tests. And I'll update you guys next week on what, you know, everything that I did. And then we can focus more on finishing the shot off. We've got this render, which is starting to look pretty cool. But the water definitely needs work. And, you know, we can get some other elements in there. So I think, yeah, there's still plenty of work to be done on this, but I'll try and get that flip sim sorted out. Cool. All right. Well, it's time for me to go. Thank you for joining me, everybody. As always, it's been fun. Don't forget to like and subscribe, and I really appreciate your support. We're getting quite a good viewership on our stream now, so let's keep it up. If you want to share it around, if you think people would like it on forums or whatever, then please share it. And thanks, Alan. Thanks for that. Thanks for joining me. And yeah, if you have any questions at any time, please post them in the comments. It might take me a little while to get back to you, but I always will. And if you have any suggestions or things that you would like to see me work on in the future, I do have a big list. So you know, I'm always adding those suggestions to the list. So yeah, I'll see you guys next week. Have a good week, everybody. Stay safe.